Find f prime at 1. So f prime at 1, by definition, is limit f at 1 plus h, f at 1, all over h. Okay, so let me replace the f with 3x squared minus x cubed. So 1 plus h squared minus 1 plus h cubed minus, let me plug in 1 in there, and you get 3 minus 1. Okay, so that's what you get if you plug in, replace x with 1s. Okay, so it's all over h. Okay, so the pattern is always the same. Let's group this one with this. That's the matching corresponding values for x squared term when you plug in 1 plus h and when you plug in 1. And I'm going to of course group these two as well. Okay, so that's what you get if you group these two. And with this you get minus 1 plus h cubed plus 1. So from these two I'm going to factor out 3. Okay, then you get 1 plus h squared minus 1. Okay, so 1 plus h squared minus 1. And instead of writing like that, I'm going to factor that. So then what do I get is 1 plus h plus 1, 1 plus h minus 1. Let me factor out a negative 1 from these two. So you get 1 plus h, 1 plus h cubic minus 1. Okay, I'm gonna look at that as a differences of cubes and factor that as well. Okay, so note that right here I get exactly h, so I'm just gonna write 3h, 2 plus h. But factor that, I get 1 plus h minus 1, 1 plus h squared, okay, plus 1 plus h plus 1 squared. Alright, so do you see that that's also h? So you can divide the top and bottom by h. So divide that term by h, and that h goes away, it turns into 1. That also h will turn into 1. And this h will also turn into 1. Okay, so what we have left over is 3 times 2 plus h. Okay, minus, in a bracket we have 1 plus h squared plus 1 plus h plus 1. Now let's replace the h with 0. We get 3, 2. Okay, here we get 1 squared plus 1 plus 1. That's 6 minus 3, so we get 3 for the derivative of the given function at 1. Okay. Okay, so if the slope is 3, and the given point is 1, 2, the equation of the tangent line is y minus 2, slope 3, and x minus 1.